choose square matrix. Since there are lots of rows and columns in the original matrix, you can make lots of minor from it. The minors are labeled according to the row and column you delete.
To better understand, looking at the question. If you find minus number 2 at the column 1 and row 1, you must delete column 1 and row 1. So you get a new matrix is 2, 1, 1, 2. To find minus number 1 at the column 2 and row 1, you must delete the column 2 and row 1, and so you can get a new matrix 3, 1 and 2, 2. Next, to find minus number 1 at the row 1 and column 3, you must delete the row 1 and column 3, and then you get a new matrix again. So you must repeat the formula until the end to get all minors of the matrix. For population minor, you can use them to formula AD minus BC. A cofactor is the number you get when you remove the column and row of the designated element in the matrix, which is just a numerical grid in the form of a rectangle or a square. Given x plus 2y plus 5z equals to negative 17, 2x minus 3y plus 2z equals to negative 16, and 3x plus y minus 5z equals to 3. Find the value of x, y, and z using matrix inverse method. Convert the equation to the matrix form. And separate the coefficient and the unknown x, y, and z in the equation into the form of matrix. So, we will take row 1 to get the determinant. Firstly, find the determinant of the matrix. Secondly, find the minor. We are using the formula AD minus BC to get the minor. Next, we need to find the cofactor. The cofactor is just take from the minor, but we multiply it with positive or negative based on the position. Step 4. We need to find the adjoint. The adjoint is just the exchange of row and column. For example, row 1 to column 1, row 2 to column 2, and row 3 to column 3. And the last step, that is, insert in the formula. The formula is inverse A equals to 1 over adjoint times with adjoint of A.
How to do the inverse of a 3 by 3 matrix? Let me show you the steps on how to do 3 by 3 inverse matrix. In order to solve an inverse matrix, you need these 5 steps. First, calculate the determinant of the matrix. Second, find the minor of the matrix. Third, find the cofactor of the matrix. Fourth, find the adjoint of the matrix. And lastly, multiply 1 over determinant with adjoint. Let me show you on how to find an inverse matrix for this matrix. To calculate the determinant, you must let E to this matrix. Then, you do the determinant calculation. After settle with the calculation of determinant, then you will get the answer is 1. Next, step 2 is to find the minor of the matrix. To get the answer of the minor, you must settle with the calculation of the minor. Step 3. Find the cofactor of the matrix. You need to get the answer from the minor. Then you need to subtract it like I put the red minus symbol. Then after subtraction method is done, you will get the answer for cofactor E. Step 4. Find the adjoint of matrix. To find the adjoint, you must transpose the cofactor. In this case, we have cofactor E. The row become the column and the column become the row. So, this is the answer for adjoint E. Step 5. Multiply 1 over determinant with adjoint. To do the inverse, we need to multiply 1 over determinant with adjoint. In this case, we have determinant is 1. So 1 over 1 will times with each element in the adjoint. So we will get the answer for inverse E.
Calculation of the matrix inverse. First and foremost, for each element, calculate the determinant of the values not on the row or column to make the matrix of minors. Secondly, apply the check part of minors to make the matrix of